Alright, so in the spinal cord, what you have is, first of all, as it runs along the vertebral column, you find that it has specific components from the neck area, which is the cervix, to the chest area, which is the thoracic area, and then you have the abdominal or the lumbar, and then you have the pelvic area, which is known as the sacral, and then you have the tailbone. The cross section of it is such that it has the center. All right, the central part looks like a butterfly. Okay, so this central part looks like a butterfly, and then it is surrounded by a whitish area. Now, the central part itself not only has a butterfly shape, but we see very distinct anatomical differences with the outside. The inner part has a lot of soma. That is why it has this gray appearance, soma or cell bodies, whilst the outer part has more of the fiber or the axonal components of the neurons. So just to take you through what we are seeing the back and the front, or we are seeing the dorsal. Alright, so we're seeing the dorsal component and the ventral. Okay? So the gray matter itself, which is the butterfly area, also has this ventral part, and it also has the dorsal part. So what I can name as the ventral horns, all right, these that appear horn-like, okay, these ventral horns, both on the left side and the right side, they have cell bodies for neurons that supply the motor component of the skeletal muscle. So whatever is emanating from here, going out of the spinal cord, is going to go and innervate muscle. So the cell body is around there, making it even darker. Then, so you have the horns themselves, the ventral horns. Then we also have some other components here, the central canal. Okay, so right at the center, we have the central canal right here. Let me paint it something else. Okay, so we have the central canal, and then we also have the lateral horns. Okay, right. We have lateral horns, and we will talk about them as we go. Aside that, there be other functional anatomies that I would like you to know, apart from the ventral horns and the lateral horns. We also have, of course, the dorsal horns. Okay? So we have these horns at the back known as the dorsal horns. So the dorsal horns receive sensation. Now, these are the starings of what we're talking about now. So they receive sensation. So what you have here is you have a receptor organ on the soma end of things, and this is connected to a sensory neuron. And the sensory neuron, as I said, you find that it has its cell body away from the spinal cord in an area known as the dorsal root ganglion. All right, the dorsal root ganglion. So it will then have its central process innervate other fibers within the spinal cord. Some of them are in this dorsal area, and others are within the layers of the dorsal horns. In either cases, you have more nuclei that receive, or rather, you have more soma that receives the innervation coming in. So again, within our central part, you see even more darker areas because of that. So basically, this is what we'll be talking about. This sensation is coming in through this area. How does it move when it reaches the spinal cord? And at a later time, we'll be talking about the motor system. But for now, we are talking about the sensory component. So why talk about the sensory component and learn about how these things move? Well, basically, it's so that we understand what would happen if there was a lesion in any one of these areas. We would know where exactly sensation would not be coming from. So if you had a lesion happening there, if this is the center, then you would know what is happening by the way we have this fissure down here. Anyone who can tell me? Yeah, the anterior median fissure, and at the back, of course. So this is the anterior median fissure, and we have a sulcus at the back known as the posterior medial sulcus right there. But in any case, so the sulcus is somewhere there, more anatomical. But as I was saying, the point of knowing these areas is to appreciate what the physiological repercussions, what physiological outcomes might be because of these insults or because of these lesions. So if it is happening here, what would we expect if it is happening at the center? What would be expected in these individuals? So basically, that is why we try to understand how these fibers move, where exactly they move, where are they coming from. So it is very important to understand the sensory component and the fact that this is the motor component, and that you have your dorsal root ganglion there, and then it enters the spinal cord, and then also to understand how they move within the spinal cord. So we'll be talking about that very soon. But just to put everything together, we are just appreciating what is happening from the receptors. Okay, so we say what is happening, what is the stimulation there. So once we appreciate what the stimulation is there, then we say, okay, what are the sensory fibers involved, and where do they synapse in the spinal cord? And in the spinal cord, once they synapse, what specific pathway, okay, what is the specific pathway that they follow in order to reach the central nervous system? This is what we're basically trying to understand. Now, while some end in the spinal cord, for instance, you guys already have an idea of what a reflex arc is. So from here, you might have this sensory the sensory component, the sensory nucleus synapse on an interneuron. So this interneuron will then go and synapse on the motor neuron, and then you have a reflex arc that is formed. So while some of them end in the spinal cord as reflexes, we have some that are consciously perceived. All right. So conscious perception is really taking it to the higher brain centers. All right, now how is it taken to the higher brain centers? What are the specific pathways? Just action potential just doesn't move from fiber to fiber. It has to follow a very specific pathway, and so that's what we want to appreciate as physiologists. We want to appreciate what's the specific pathway, and then try to work back and say, if a lesion had to happen there, what physiological components will be affected. So remember, the spinal cord has the dorsal, the lateral, and you have so dorsal, lateral, and ventral parts. And then one thing that you should know is that on the dorsal part itself, you have ascending fibers that go up in what is known as a dorsal column. All right, so we're going to talk about that, the dorsal column. So these ascending tracts, they carry specific type of stimulation. Then we also have some that ascend through the anterior component or the ventral component. So that is this area. So that's the ventral component. And then you also have some that go through the lateral component. So this anterior lateral pathway will also be discussed as one pathway. So we will discuss, number one, the dorsal column, or the dorsal pathway, column pathway, and then we will look at the anterior lateral pathway or the ventral lateral pathways. So just to give you an introduction, the dorsal column expresses sensation with very high myelination. So if there's high myelination, my physiology students would know that we are looking at very fast speed and therefore very precise sensations. The dorsal column, and because of this factor, also have pretty high accurate information, and that is more localized. And we talked about all of this when introducing the receptors. So aside that, we should also note that the dorsal column carries sensations from most of the mechanoreceptors. So when we talk about dorsal columns, we're talking about things such as fine touch, all right, and then we'll also talk about vibration. When there is vibration, you want to feel the sudden change of sensations from one part of the skin or the soma to the next, the somato area to the next. So vibration has to go through this area. Another component that you want to really discriminate is exactly that, the 2-point discrimination. How do you tell one point from the other? That is high accuracy, so it goes through the dorsal column. Where you are in space and time is known as proprioception. It is very important for you to know where you are in space and time, so that once you want to carry out your motor movements, of course, you carry them out with precision. So you just imagine how it would be if you didn't know where your leg was or where your hand was, and you wanted to, I don't know, do some dance. So proprioception is not only good for dancing, but of course for major motor movements, you have to know where the muscles are in both space and time. The anterior lateral component carries sensations such as crude touch. Now, when we're talking about crude touch, we're talking about a very rough type of touch where it's not very precise. Someone would say that touched me somewhere there, all right? Then we're also talking about pain. In as much as we can say that you're feeling pain, you can't literally point to say the pain is coming from. There will be an area where the pain will be coming from. So it makes sense that it goes through this much slower set of fibers. The next one that is carried through these fibers is, of course, temperature and tickle. We also have sexual sensations go through this area. So as we talk about all of this, we will indeed just appreciate the fact that we are talking about a type of pathway that is really fast, precise, accurate, versus one that has less precision, less localized. And that's how we're going to appreciate these two in the next video.